This is lesson 2.2 out of the Ratios, Rates, and Statistics book. In my class, that is on page 109. And lesson 2.2 is titled Repeating Decimals and Rounding. Now, rounding decimals is something we did way back at the beginning of the year, but we'll be talking about that a little bit again. Repeating decimals is new, although if you're in my class, we've talked about it before. You'll be familiar with what you see in this lesson. All right, so warm up. Find each unit rate. All right, so number one. Oh, I should explain this. In my class, we do 2.2 and 2.3 backwards because it just happened to work with the schedule we had better, and one wasn't dependent upon the other. So the warm-up I do here, if you're doing these in order, won't make any sense to you, so you'll probably have to just skip it. It will make sense to you when you do 2.3. All right, so 40 miles per 5 minutes equals how much? Unit rate. Number two, 64 miles per 3 gallons equals unit rate. And number three, $4.40 for 4 hot dogs equals, what's the unit rate? All right, and for I can statement, we've got I can convert fractions to repeating decimals. We got 2 I can statements. And I can round numbers to a given place value. Okay, that's our goal for this lesson, and we'll section it off and start our notes. Okay, so I have just one vocabulary slip, and I'm going to put it in the usual upper left spot. Tiny tadpoles. Teeny tiny little smears of magical Elmer's glue. Needs so little to do the job with paper. All right, press it, and we're ready. Okay, so vocabulary for this lesson. First, we will talk about what it, oops, wrong one. First, we'll talk about what is a terminating decimal. That is a decimal that stops. Okay, so if you have a decimal number, if you're doing a division problem and it doesn't go on and on and on and on, it stops at a certain number, you finally get a 0 at the bottom of your division problem, that's a terminating decimal. The opposite of that would be a repeating decimal. It's a decimal where one or more digits repeats forever and ever and ever and ever and ever. And then, and we're not talking about that in this lesson, there are the irrational ones where the decimals go on and on and on and on and on and on and on forever, never repeating. And I bet everybody can think of at least one that they know of. How about pi? we round that to 3.14 because the numbers after the decimal go on to infinity and beyond and never repeat. But we're not talking about those. You'll talk about those much more when you get into higher levels of algebra. We're talking about terminating decimals and repeating decimals. All right, so the good to know down here talks about when a decimal is a repeating decimal, you write the repeating pattern once and then draw a bar above the repeating part of the decimal. That's what shows you that it's repeating. So right here they give you the example 1/3. Well, a third of anything, whether it's 1/3 or 2/3, is always going to be a repeating number. And in this case, it's 0.33333 on and on and on and on. And so 1/3 is usually expressed either as 0.3, where we put the bar over the 3, signifying that it goes on and on, or they might round it. So then if I said round it to the nearest tenths, then it would simply be 0.3, because the number at the next in the hundredths place is a 3, which makes this 3 stay right where it's at. Remember your rounding rules when we talk about decimals. And again, if you don't, we'll talk at the end of these notes about how all of that is back on page 4 in lesson 1.2. We did that at the beginning of the year. Okay, so let's talk about how this repeating decimal thing works. All right, so we're going to make a little note over here. There's really not much to it. This lesson is quick and easy. We're going to make a little note over here that says, we'll be talking to ourselves. This division problem keeps going on forever. Have you ever been in that situation where you're doing a long division problem and it just keeps going on and on forever, and you think you've made a mistake because you can't figure out how to make it stop? Well, if it's the same number or numbers, I'll show you what I mean, repeating over and over, then put a stop to that. Crazy. All right? So, this division problem keeps going on forever. Well, if it's the same number or numbers repeating over and over, then put a stop to that crazy. And we do it with the little bar that signifies this is a repeating number, and I am not going to go any farther with it. So, here are some examples. All right, the first one is, and I kind of mentioned this earlier, so A. The first one is the fraction 2/3. If I'm going to convert that into a decimal, well, I know I have to divide the numerator by the denominator, so that means 3 divided into 2, but 3 can't divide into 2, so that's where I add the decimal and the 0, put that decimal straight up there. Put the placeholder 0 here that tells me 3 does not go into 2. All right, and then, but now 3 can go into 20 6 times. 6 times 3 is 18. When I subtract, I'm left with 2, not a 0, so I have to add another 0 and bring it down. Now 3 goes into 20 6 times. 6 times 3 is 18. You see in a pattern now, and that leaves me with 2. So I have to add another and bring it down. 3 goes into 20 6 times. 6 times 3 is 18, which leaves me with 2. So I have to add another 0 and bring it down. 3 goes into 20. And 6 times 3 is 18, which leaves me with 2. All right? On and on and on and on, and that'll just keep right on happening, right? So we don't want that, right? All right, so what we want, in fact, just you saw how this works. I'm going to subtract some of this. Let's see. What did I do? 2 18s and the 20. So I've got some room for some more notes below it. You get the picture here. It'll go on and on. All right, so what happens then is 2/3 is equal to 0.6 with a bar over the top of it. And that tells me that this 6 will repeat infinity. All right, I'm going to take my red and I'm going to outline this. And I'm going to write above here, repeating. And that's what this means. Need a little sharpen on my red here. Okay? Now, here's another example. B. Let's say I have 1/11. Okay? And on this one, 11 has got to divide into 1. Well, it can't. So I'm going to add this 0. Right? And I've got 0, put that decimal right up there. Well, 11 can't go into 10 either, so that's another 0, and I've got to add 1 here. But 11 can go into 100 9 times, correct? And 9 times 11 is 99. It's going to leave me with 1, and I bring down the 0, and I'm going to have to put 11 into 10 again. And that is going to repeat over and over. 09, 09, over and over again. All right? So, you see that instead of the 666666 that would have repeated, I have 09, 09, 09. I have 2 numbers that are repeating. And so to write this, 1/11 equals 0.09 with the bar all the way over the 0 and the 9, because it's the 0 and the 9 that are repeating, not just the 9, right? That's how that would work. So we're going to write a little note about that here. The bar is over the 0, 9 because both repeat. Okay? That's what's happening there. Okay? That's how we do that. Now, the last thing I want to do on the notes here is I'm going to put a big red star here, and we're going to make a note about rounding. All right? So, sometimes you have to round instead of using the bar, the repeating bar. And often your problem will ask you to round to a certain place value. Okay, so when this is the case, see page 4, lesson 1.2 for rounding with decimals steps. Okay, you should know this, but if you need a refresher, that's what I'm telling you. Go back to this lesson here and get a refresher on how to round with decimals. All right. Okay, so that's the notes for lesson 2.2. And so now we'll take a look at some practice problems. Okay, so practice problems for lesson 2.2. The first three at the top here are simple convert each fraction to a decimal, and you will get repeating decimals. So remember the rules we put into your notes for that. Numbers 4 and 5 are asking you to round this number to the nearest hundredth. Now, the thing you need to remember when we're doing this, we didn't do this in the notes, so I'm going to explain a little bit. The bar over this 6 means that 6 repeats. If you're going to round to the hundredths place, you have to know what's in the thousandths place to tell you what to do with the numeral in the hundredths place. And so even though it doesn't show you a number out to the hundredths place, this tells you what the number is in the hundredths place and the thousandths place, and so on, because it's telling you this number repeats. So bear that in mind when you think about how you should round that. Again, refer back to the beginning of your notes book if you can't remember how the rounding rules work. On number 5, you're going to convert this 1/3 to a decimal, rounded to the nearest hundredth. Again, your rounding rules. Go back and refresh your memory. Okay, so let's see how these work. Number 1, we've got 1/3. I've got to set up a 3 divided into 1. Well, 3 does not divide into 1, obviously. So we put the decimal straight up. We put a 0 here and a 0 here. 3 can go into 10 3 times. 3 times 3 is 9. And when we subtract, we're left with 1. So we add another 0 and bring it down. 3 goes into 10 3 times. 3 times 3 is 9. When we subtract, we are left with 1. So we add another 0 and bring it down. Can you see the pattern? Yes, it's going to go on and on and on. All right, so what we would do here is 1/3 is equal to 0.3 repeating, with the repeating bar over it. All right, okay, so number 2. Same process, but we're going to divide 6 into 5. Put that decimal there and straight up into the problem and a 0. 6 cannot go into 5, so we put a 0 there. But 6 can go into 50. It goes into 50 8 times. 8 times 6 is 48. And so when I subtract, I get a 2. So that's not a 0, so I'm going to add a 0 here and bring it down. 6 can go into 20. How many times? 3 times. 3 times 6 is 18. When I subtract, that leaves me with 2. So I'll add another 0 and bring it down. 6 goes into 20 3 times. 3 times 6 is 18. That leaves me with 2. So I add another 0 and bring it down. 6 goes into 20 3 times. Do we see the pattern? Sure do. All right, so 5/6 is equal to 0.83. Now remember, we only put the bar over the number that repeats, not the 8. It's not part of it. That would mean then that the equivalent of 5/6 is 0.83838383, and that's not the case. It's 0.83333333, and on and on. All right? Okay, so last one. Now we're going to divide 9 into 1. Get that decimal here, put it straight up. 9 does not go into 1, so we put our placeholder 0 there. 9 does go into 10 one time. 1 times 9 is 9. Subtract it, that leaves me with 1, so I'm going to put another 0 here and bring it down. 9 goes into 10 one time. 1 times 9 is 9. That leaves me with 1, so I'm going to put another 0 here and bring it down. 9 goes into 10 one time. 1 times 9 is 9, and so on. So I've got a repeating number on that one. It is equal to 0.1. The 1 repeats. All right? Okay, so that's how we do those. Now, I kind of explained this one pretty well to you, I hope. We want it rounded to the nearest hundredth. So I'm going to rewrite this as 4.66. Well, there's my hundredth place. And in order to know what to do with that, I need one more number off to the right that tells me. That's the thousandths place. And I know that these 6s will go on and on and on and on because that's what that repeating bar tells me about that 6. So if I have to round to the hundredths place, this 6 tells me what to do with this digit. And this digit is above 5. 5 or above, then we raise the number, right? So 4.6 repeated, rounded to the nearest hundred, is 4.67. And now we don't have a repeating bar anymore. We've just rounded it to get away from doing that. And that's often what's done with these kind of numbers. This is something you see in math, not so much in real life. In real life, you'll see it more rounded at some point. All right, so convert 1/3 to a decimal rounded to the nearest 100th. Well, we already did the conversion of 1/3 up here, right? We know that 1/3 is 0.3 repeat. All right, but now we want to round it to the nearest hundredth. So I've got 0.3 is the tenths, 3 is the hundredths. I need one more to tell me what to do in that hundredths place. Well, 3 is below 5, so this number stays the same. So the answer is 3.33 when it's rounded to the hundredths place. All right, so that's your practice problems. Let's take a look at your worksheet. Worksheet, the first step is converting the fractions to the decimals. So these are just going to be straight divisions until you see the pattern start and use your repeating bar. This one here, what I want you to do before you even start working is round each number to the nearest tenths place. Circle that tenths. All right. Remember, if like this number, it's not showing you the number in the hundredths place, which you need to see to tell you what to do in the tenths place, then remember that number is there. This number is being repeated. There's a 1 there. Right? This one is telling you to round to the tenths place. It doesn't matter that these are being repeated. This number tells you what to do with this number. Correct? All this means is that if you went on and on, it would be 5, 7, 5, 7, 5, 7, and so on. Okay? Keep your place value in mind. If you need to look at your place value chart back in the very first lesson of your notebook, do so. All right, and then that, here, now we're looking at the hundredths place. My suggestion that I always tell my students when we're rounding is your first step after you circle the instruction here is to underline tenths. Okay, that's this one here. Tenths, that's this one here. What is the number in the place value they're asking you to? So hundredths, what is the number in the place value they're asking you to round to? Then you look to the number to the right to tell you what to do with the number in the place value they're asking you to round to. All right, so then the next one down here is convert each fraction to a decimal, then round the answer to the nearest hundredths. Okay, so now you're kind of doing the division problem first till you start seeing the repeating, and then you've got to get out. So if you're going to round to the hundredths, you've got to keep dividing until you have something in the thousandths place in your quotient, in your division answer. So then that's the number that tells you what to do with the number in the hundredths place. And then this one here, Ted's bank statement showed that he had this much in interest in his savings account. The bank put this much into his account based on this figure. See if you can figure out why. Compare these two numbers and figure out what is going on. All right? And then the last thing, in my class, we will discuss this in class, and I don't want you to do it as part of your worksheet. That's a really confusing question to ask because there's really more than one way to look at it. So we will discuss that one in class. I don't want you to do it as part of your assignment. Okay, so that leaves us with your exit ticket. Your exit ticket for 2.2 is right here. This is just extra practice. I don't give you the answers or tell you how to do it. We can straighten it out a little bit though, huh? Okay. All right, so that's lesson 2.2 in your ratios, rates, and statistics book. Remember, The only way to learn math is to do math, and mistakes are proof that you're learning.